Now we are going to discuss the question from signals and systems given in GATE 2001 from the property, the classifications on the signals. So here the impulse response function of four linear systems S1, S2, S3 and S4 are given respectively by h1 of t equals to 1, h2 of t equals to u of t, and h3 of t equals to u of t by t plus 1, and h4 of t equals to e power minus 3t u of t. So here where u of t is the unit step function, which of these systems is time invariant, causal and stable? So it has to the impulse response has to satisfy the three conditions: the time invariant, causality and stability expression. Then we will see. So here coming to the h1 of t, coming to the first impulse response h1 of t. So solution, coming to the h1 of t is equals to given as 1, nothing but for all values of t, the h1 of t is nothing but given as the value 1, given the value 1, nothing but for negative values of time also, we have the amplitude. Then it is not satisfying the condition that h of t equals to 0 for t less than 0. We know that this is the condition for causality of the system. So whenever this condition is satisfied, we can say the system is causal. Here h of t is not equals to 0 for t less than 0, then this condition is not satisfied here. Then we can set the given, this is h1 of t, then the given h1 of t is not a causal system, this is non causal. So no need to go for checking the another properties. Then we can decide that S1 is not the answer. S1 is not the correct answer. Now let us consider the third one. That is h3 of t equals to u of t by t plus 1. h3 of t equals to u of t by t plus 1. Then here we know that given this as u of t is nothing but u of t equals to 1 for t greater than 0. Then this value is having only for the t greater than 0, that is h3 of t equals to 0 for t less than 0. Then we can say this is causal. The first condition, the first property is satisfied. Coming to the time invariance property, invariance property. So the time invariant is nothing but the system characteristics does not vary with respect to the time. That's we need to check here. So in order to check that, we need to find the output for the shifted input signal x of t minus t naught. The output for the shifted input signal is represented with y of t comma t naught, that is obtained by placing the transformations on x of t. That is, the transformations on x of t is nothing but the input signal. The transformations on x of t minus t naught we need to consider here for the shifted input signal, and we'll introduce the same amount of shift in the output, that is y of t minus t naught equals to, that is transformations on x of t at t equals to t minus t naught. That we need to check here. So here by checking that condition, here let us consider here given that the input is u of t for the input is u of t for the system. Let consider that u of t is the input. So by taking the shift in this u of t, that is u of t minus t naught, the output becomes y of t comma t naught equals to u of t minus t naught divided by, from this expression, t plus t1 will get, and introduce the same amount of shift in the output, that is h3 of t, then y of t minus t naught equals to u of t, that is obtained by replacing the t with t minus t naught. So u of t minus t naught divided by, this becomes t minus t naught plus 1. We can observe that these two are not equal. Then the system, we can call it as the time variant system. We can call this as time variant system. Then this is not satisfying the time invariance properties, and we can decide that S3 is not the correct answer. Coming to the S4, nothing but H4 of coming to the H4 of e power minus 3t, H4 of t, that is e power minus 3t u of t. So H4 of t equals to e power minus 3t into u of t. Now check the causality condition. Here also u of t is given, that is t greater than 0, and then we can set that h4 of t equals to 0 for t less than 0. Then this is causal system. Now we'll go for the time invariant property. Whether it is time invariant or not. So for the shifted input signal u of t minus t naught, the output is represented with y of t comma t naught equals to e power minus 3t into u of t minus t naught, and the same amount of shift is introduced in the output, that is y of t minus t naught, replacing the t with t minus t naught. This becomes e power minus 3 of t minus t naught into u of t minus t naught. Then we can set y of t comma t naught is not equals to y of t minus t naught. Then the system is time variant. Then this is also not satisfying the time invariant property. Then S4 is also not the correct answer. Then we can set S2 is the correct answer, that is u of t. So we know that u of t is a causal system, and y of t comma t naught becomes u of t comma t minus t naught, and y of t minus t naught becomes u of t minus t naught, and it can satisfy the stability condition also. Then the answer is S2, that is option B here.